All right, quiz 1. So, rank the bonds from shortest to longest. So this is all about comparing. So carbon's the same in all of these. The difference is fluorine, chlorine, and bromine, and where they're at in the periodic table. They're all in the same column, so it's going to be a difference in size. So there's the larger the atom, the longer the bond. So bromine is the largest. That's going to make the longest bond to carbon. Fluorine is the smallest, so make the shortest bond, most orbital overlap. So that's the ranking there. Here, phosphorus goes in the middle. There's no overall net charge, right? Usually put the oxygens around it. The H goes on an oxygen outside. Doesn't usually end up on phosphorus. Phosphorus can have expanded octet because it is one column. It is in the second row, so it has a little more expanded octet. What type of hybrid orbital are the lone pairs located in? So this sulfur is sp2 hybridized because it has one pi bond. That means its set of hybrid orbitals would be P, sp2, sp2, and sp2. So this is being used for a pi bond, this is being used for a sigma bond, and then these two are being used for lone pairs for the sulfur. So hybridization state of the sulfur is sp2 because it has a pi bond. So I should know that as well. What hybrid orbitals are formed in the sigma bond between the carbons above? Again, this carbon is sp2 hybridized, this is sp3. So again, this carbon in this case, right, is using a p orbital for a pi bond, and the other three sp2 orbitals is using for sigma bonds. So it's sp2 from this carbon, and this carbon is sp3 hybridized, so all the orbitals are sp3, so it's sp3 to sp2. Now for these ones, looking at how many pi bonds it's bonded to, bonded to 2, so it's sp hybridized. Notice the boxing for hybridization state. Carbon with no, not bonded, no pi bond, so it's sp3. Nitrogen with no pi bonds, not next to a pi bond, is sp3 as well. Draw the pi bonds between the carbon and nitrogen below. So I just wanted to see this actual 3D picture, so you can see these are both carbon and nitrogen, both sp hybridized. Notice how these are perpendicular, 90 degrees. These p orbitals and pi bonds are 90 degrees away from each other. Also notice that the nitrogen has a larger lobe because the nitrogen's more electronegative. Molecular formula for filarin, a COVID drug, just numbering out number of the carbons and the hydrogens and the oxygens, and then make sure you add all the lone pairs in, all these oxygens as well. Biggest hard part here is finding all those hidden hydrogens. So let's practice finding those hidden hydrogens. All right, last question was pretty tough. People didn't see this hidden hydrogen on this carbon here. This carbon had a hidden hydrogen, right? That's how this got a lone pair. So this nitrogen is a negative charge. Put all the lone pairs in. Nitrogen lone pair goes there, takes that H. That's what forms the 2 electrons here, form that new bond. That breaks this CH bond, and that gives the negative charge in that carbon. If that carbon is a negative charge, it has to have a lone pair. So thinking about bonds broken, bonds formed if you're given the products. Slow down and think about those hidden hydrogens,